Okay, so today we'll start the statistics class. As you know, statistics is another branch of mathematics. So, where we study about collecting, analyzing, interpreting, presenting, and organizing the data, right? So, mainly we have some hypothesis, we have some unique tests that we want to do. So, for that, we collect the data and we try to see if certain hypothesis holds true. Okay, so that entire process will be a part of statistics. Now so you collect the data. So there are certain ways to do that using programming, and while you do the collection, there are a lot of steps involved. After collection you have to clean the data and then make it available for interpretation, and that interpretation of the data is called as descriptive statistics. And then you have to understand how the future values may fit into the historical data. So all of that you have to do. Those are all the parts of statistics. So mainly there are two types of statistics, okay, broadly speaking. So the one is descriptive statistics, one is inferential statistics. Descriptive statistics is where you describe the data. You collect the data, you understand it, you summarize it, you make sense of that data using various um, calculations like mean, median, mode, standard deviation, variance. So all of those you use to understand the data, describe the data basically. And then there is a univariate analysis, bivariate analysis, multivariate analysis. All of those will become the part of descriptive statistics. Now inferential statistics is where you are trying to prove certain thing, okay, where you perform certain tests and you come up with certain hypothesis, and to that hypothesis you try, either you try to prove it or you discard that. Either you accept the hypothesis or you reject the hypothesis. So that is done using a p-value measurements that we will see in inferential statistics. And not only that, you also try to compare the results from various distributions like what we talked about, ANOVA, or maybe doing your t-tests. Okay, so all of those f test, t-test, so all of those will be a part of inferential statistics. Okay, so even before going to the statistics, we have to understand what data may look like. Okay, data is of essentially two types: qualitative data and quantitative data. Now qualitative data is mostly categorical data, okay, and quantitative data is numerical data. Again, in numerical data then you have further more divisions, okay. So something like nominal data, ordinal data, and then discrete data, okay. And then in categorical data also you have some sort of order involved, okay. So mostly ordinal data applies to categorical data only, okay. And something like occupation, okay, occupation has no order, okay. Whereas education has order. LK, secondary education, primary education, right? Primary education, secondary education, then graduate level, postgraduate level, then PhD level. So all that follows a order. So that is called as ordinal data. And the data in which there is no order is called as nominal data. So that way there are classifications of data also. Mostly to describe the data we have various representations, mainly like bar chart, pie chart, okay, line graph, okay. Pictograph we use very less actually. And then histograms is very extensively used. And then frequency distribution, we don't use frequency distribution, we rather use histograms. And then to check the outliers we use box plot, okay. So all of those things we will see. And there are certain terminologies that we have to understand, okay, starting with mean. Okay, mean is the basic terminology we have to understand. Mean is nothing but average. Here as you can see I have defined an array, okay. And actually I have defined a list, I am converting that list to an array. Now y is my array. It consists of values 2, 4, 6, 7, 20, whatever random values. And to that I'm calculating the average. So mean means average. Okay. So when you do the calculation, the average becomes 10.14. Okay. And median is nothing but the centermost value. What is the centermost value if you notice here? So there are three values after this and three values before this, hence the centermost value is 7. So hence the median becomes 7. Mode is the most repetitive value. Here in this case there is no mode because there is no repetitive value. But if you see this example, here 1 is repetitive, 3 is repetitive, 4 is repetitive. Here mode becomes 3 because that is the most repeated value. Okay, mean, median, mode are the very basic terminologies, and on top of this we will learn what are other terminologies. Okay, the next terminology we have to learn is standard deviation. Now standard deviation is nothing but, let's just say you want to know, you calculate this average, right? You wanted this average calculation. Let me explain this in a better way. Let's just say you have scores of students. Someone scored 60, someone scored 60, 54, someone scored 35, someone scored 90, someone scored 96. Okay, whatever the scores are. So you want to know the average of this. Okay, if I apply dot mean, but I have to convert this to np dot array. So if I calculate the average, average is 67. Okay, now standard deviation means how far, or how many marks could this person who scored 35 would have obtained to get the average score. Okay, the difference between this average mean and the data point x. Okay, so that difference you can take it as standard deviation. Okay, how far away the point lies from the mean. Okay, so that would be standard deviation, or mean deviation, or the standard deviation. Okay, is nothing but the absolute difference between the items in distribution of the mean or median of that series. Okay, so how far away is the point from the mean, that is called as mean. The standard deviation is a measure of amount of variation of set of values. Okay, so standard deviation, if you do this mean deviation calculation, which is for example here, if you notice 67.0 minus 35, how far away this person could have, what how far away is 32 marks. This fellow fell short of securing the mean average number. So we say 32 is the mean deviation. Okay, and standard deviation is the measure of how much is the variation of the set of values, how much values are varying, the difference in the values, each one of these values, that will give you the standard deviation. Okay, and you take a square of that, square root of that, sorry, the square of that standard deviation, then you will get the variance. For example, so if you notice 60 minus 35, so if you calculate 60 minus 35, so sorry, average is 67. 67 minus 60, first person scored 60, so he is 7 points away. And likewise 67 minus 54, 7 minus 54 will give you 13. Okay, so 35, we already have calculated this I will copy paste here. So likewise, if you calculate all of these values, how far away are these points allocated? How far away are the scores? Okay, see this minus 23, again 96. So if you know 67 minus 96. So all these points, some are positive, some are negative. Basically, the average was 67. So this point we can say 60. This person scored 7 marks less than the average. This person scored 13 marks less than the average. This person scored 32 marks less than the average. These people scored higher than average. Okay, 23 and 29 respectively. So if you subtract minus mean, actually I have taken my mean minus this value, it has to be value minus mean, but either way, whatever it is. So these variation, these spread of values is called as variance. Okay, there is a huge difference, right, between the values. Someone has a difference of positive 29, someone has a difference of minus 7. Okay, whatever the differences is, so this is called as variance, and if you take a standard square root of that, you get the standard deviation. So for us, you can see the formula also. So a point minus mean. Okay, x of I is the point marks minus mean. I have done the opposite here actually. So it should have been 60 minus 67. Okay, here it should have been 54 minus 67. So that way, if you calculate, so you'll get this person has fallen short by 7 marks, this person has fallen short by 32, likewise this person has fallen short by 32 marks from the average, right? And these people have exceeded from the average. How many marks exceeded? 23 and 29 respectively. So if you do this calculation, you will get the mean deviation, and to that mean deviation, if you divide by total number of values, how many values are there? Five scores are there. Okay, so 5 scores are there. So for if you divide that by 5, then you will get the standard deviation. Okay, so that is about standard deviation. And if you take a square root of that, you will get the square of that. Sorry, square of that. If you take the square of that, because you have negative values, right? You want to get rid of these negative values. So what you do is you square them and take the square root ideally. So that will give you the positive standard deviation. Anyway, so basic definitions. Okay, for us, we don't have to worry about all these calculations. We don't um, even look into this. Instead, what we do is we directly have functions for that. If you want to calculate the variance, you can just calculate the variance for array A. Okay, this is my array. Let me print what A looks like above here. So let me execute this. And what is the A? A looks something like this. These are let's just assume that these are the scores between 0 to 15, or 0 to 20, whatever. For 20 marks, these are the scores of various subjects by certain student A. And likewise, if you want to calculate the variance, you can simply pass the function np dot var. Okay, if you want to calculate the standard deviation, you can pass std. Okay, you have std there. You can pass the std of A, and then you will get the standard deviation is 3.25, which means, what it means is, from 3.25, so you if you take the average of this entire thing, okay, np dot mean of A, what it means is each student on average is 3.25 points away from the mean. On average, each student is, or each scoring is 3.25 points away from the mean. That's what it means. Okay, this was an interview question as well. Okay, when so someone did calculate like this was a data. Someone was given an assignment. Okay, they they ran a describe function on top of this data. Okay, and then they got standard deviation. So this was an interview question. So randomly the interviewer picked a question, or picked a value, and for that he has to explain what does this value mean. Okay, so what does this value mean? Standard deviation, what do you understand from these values? And the student was unable to answer. Okay, I mean the interviewee was unable to answer. So that is what standard deviation means. On an average, how far away your point is from the mean. That is what standard deviation will tell you. And if you take the square of this, you will get the variance. Okay, so just understand that much, that would be sufficient for you. Okay, and here we have calculated the standard deviations for each one of those above values. Okay, so these are basic terminologies in statistics, but we want to have a look and understand how these statistic concepts are being applied. That's why I have downloaded a train.csv file, and I've kept it in data sets. This I will upload to the folders. Okay, so here we'll make use of pandas. Okay, if you do we have a library called pandas, and we have a library called seaborn. Seaborn is used for graphing library, used as a graphing library, and matplotlib also is used as a graphing library. So you can interchangeably you can use both of these. Okay, and pandas you can use to apply functions on a data frame, whereas numpy can be used to apply a various functions on arrays. This works on arrays or series. This works on data frames. That is the difference between the two. Okay, so this is applied for arrays or pandas series. There is something called series, pandas series, which is same as array. In other words, it's array. Simple. So this is data frame. Now data frame is nothing but multi-dimensional array. Multi-dimensional array. Okay, multi-dimensional array we already have seen, right? 2 dimensions. So this is 2 dimensions. Okay, I mean if you take one row only, one column only, then it becomes 2 dimensions. But because this has 81 columns, it becomes 81 different ways the data is arranged. Okay, and five rows are there, right? Anyway, don't worry about the dimensions. We'll see the dimensions. For that also we have function if you want to understand. Okay, so it's a 2 dimensional array. Okay, so entire data that you see here has 81 columns and 5 rows, but the dimensions are 2 only. 2 because you are representing them side by side. Okay, not basically if you convert this entire thing into array, you will get 2 square brackets only. Okay, so 2 dimensions data. Anyway, so that's a different thing. First what we are doing is we are using pandas to read the file, and to read the file we have something called pandas.read csv. Now pandas, if you see the directory of pandas, you have huge number of reading. Even to read there are so many functions. Okay, with pandas you can read from clipboard means anything that you have copied that you can read. Okay, if you will do this, right click copy on from the internet. If you right click and copy, that will be copied to a clipboard, and that also you can directly paste using read clipboard. So read csv is reading the csv files. Csv files are nothing but comma separated files. You can read excel, you can read feather type, you can read fwf gap. So html json, you can see there are so many types. Sparky file is mainly used for spark data frames. Okay, there we make use of it. Then pickle is for serializing the model. SQL query, SQL table also you can read. Stata type is another library. So for stata types also you can read table. Okay, read table I think we have already used um, in probability. So these are various types of files you can read. Okay, using pandas. Here we are reading a CSV file, and you have, while reading the CSV file, you have to provide the folder. So data sets folder is where it is, this file is located. So you can provide that path. It will read. After reading, you can confirm whether it has read by running the data.head. Data.head means it will read top 5 rows. Okay. Data.tail means it will read bottommost 5 rows. Notice, so notice the values here. It is reading 1455, 56, 50 up to 59. Okay, last 5 rows are read. If you want to read last 10 rows, you can provide last 10 rows also. Okay, if you want to read last 20, so you can provide 20. So that way you can read last rows also. You can, same thing you can do for head also. You can provide 15 to read top first 15 rows. Okay. um, Shape, if you run shape is important. Okay, you have to remember this. Shape will fetch what are the rows and what are the columns. Okay, and if you notice it is a tuple. That means if it is a tuple, you apply indexing, and you can access the first value only. Number of rows you can access, or you can access the number of columns also. Okay, so this way. And dimensions, you can check how many dimensional value it is. Mostly you will work on, if you work on tabular data, mostly you will work on 2 dimensions only. If you work on images, you will work on 3 dimensional data. Okay, again video would be 4 dimensional data. Okay, text is again, that's a different story. But for tabular data, you just remember that it is usually going to be 2 dimensions only. Okay, so describe function you will apply to understand what the data look like. Okay, for each, ignore the id column because it represents only the number serial numbers. For example, if you notice sale price is at what amount the value, at what amount the price was, item was sold. If you I can apply transpose also. This we saw in matrices, no, because this is a matrix only. We learnt in linear algebra that you can convert a function into a matrix, and matrix is nothing but your data frame. Hence you can apply a transpose function. If you apply a transpose function, you can see this entire rows have been converted into columns. Okay, and columns have been converted into rows. Okay, so now I can easily read through and explain you what this is. For example, if you want to consider year sold, okay, or sale price, so there are 1460 number of count means so many values are present. Mean is on average each product was sold for 1,80,000 on average. Each product was sold for 1,80,000. And which year they sold? On average, most of the products got sold in 2007 year. Okay, and likewise, what is the pool area for which they got sold? 2.75 square feet, something like that on average. Okay, this is how you read the averages. This is mean. Now this is standard deviation. Standard deviation means, what you mean is, if the if how do I yeah, first floor, fine. So this I'll explain. So if the average square foot area of the first floor of the house built was 1162, then standard deviation happens to be 386. What it means is, on average, each for all the houses, 1000, how many thousand houses are there? 1460 houses are there. For on average, for each one of those houses, there is a difference, either positive or negative difference of 3860. 3806 386 difference for each one of those houses from the average. Okay, that means on average, if you start plotting the first floor square foot area of each of those 1460 values, then you would see 386 is the standard deviation. That means on average each house is deviating up to 386 points from the mean. Okay, that is what it means, standard deviation. And minimum value is, the smallest house has 334 square foot of area, and 25% of those houses have 882 square foot. 50% of those houses have 1087 square foot, and 75% of those houses have 1391 square foot, and maximum value, biggest house has 4692 square foot on the first floor. That is what it means. Okay, this is how you understand the describe function. First, after reading the data, okay, after reading the data, what we are doing now is descriptive statistics. This is how you do descriptive statistics. Always after reading the data, you go ahead, understand the shape of the data. You understand, you need not type the dimensions. Okay, it will be two dimensional only. Understand the shape of the data. Print head, print tail to check if there is anything unusual you are seeing in the data. Okay, and then run the describe function. Okay, this is your procedure you have to follow each time for all your data analysis, okay, that you do. So then run the describe data. After describing, you don't just run it and you will get some values and you move on. No, this is where for each and every row you have to understand how the values are changing. So this is the average, this is the standard deviation. That means, so on average the values are deviating by a huge value. Okay, that means it is not a standard deviation. This is not a standard normal distribution. What is the standard normal distribution? This is the normal distribution. For us to build a robust model, we need to have standard deviation, sorry, distribution in this form. We don't want this, we don't okay, this is fine. because this represents the same thing. We don't want this, we don't want this, we don't want this, we don't want this. Okay, we don't want this also, Poisson also. What we want is normal distribution. Only if normal distribution is there, we can apply certain algorithms easily. Again, there are certain other tree based algorithms that don't need this, but anyway, for certain algorithms we need the distribution to be normal. That's why we need to understand each and every value of this. So here we are seeing, if the standard deviation was very very low, like this value, then this is close to normal distribution. Okay, but here it is, the deviation is huge. That means value spread is high, values are spread high. That you will see, I will show you what the plot looks like for MS subclass versus overall condition. Okay, then you will understand. Okay, anyway, we have to also see the max value. Max value is a potential indicator of outliers. Okay, if your average is, if your average is 5, minimum value is 1, okay, highest value is 9, that means the plot would be something like this. Okay, I mean, I will show you by plotting. Okay, that way you have to understand each and every um, feature as a data scientist. Okay. Okay, next thing is, we have added a decorator. We have lots and lots of decorators provided by Jupyter Notebook. This is a Jupyter Notebook decorator which helps us in giving this. It automatically builds this value. If you don't run this, okay, so you won't get that. Instead, this functionality is provided by Jupyter. You don't have to write this functionality or anything. All you have to do is load extensions. Somewhere above here we have we might have loaded the extensions. Okay, see, from IPy widgets import interact, right, comma, if you give some more, there are lots and lots of them, button controller, huge number of um, widgets are there. Okay, very important widgets, that too. You can, I'll just quickly type most important widgets for Jupyter Notebook. This is a very important thing that you have to make use of. 18 must have. So some of them will look, for example, I'm using interact, right? So spell checker you can use. If you're using debugger, you can use. Okay, um, so hinterland you can use. So if you type the first letter, it will highlight. Tree filter you can use. Git plotly. Okay, nbdime code filters. So there are so many. Okay, now I think this is much older information. Now I have seen even better. This is 2023 information. I've seen even better widgets, interactive widgets. Okay, so which, when you do a data analysis, you should use them. Okay, um, so this type of functionality is offered. Okay, otherwise if you don't use this widget, you will get only this plot. Okay, if you want to make it interactive, you can make use of that. See, interactive, you can apply interactive to this function. So we are using interactive only, interact we are using. Likewise, you can add sliders, float sliders, check boxes, whatever you want, you can add. A lot of them are there. Okay, so you can explore on that. I will leave it up to you. So for now, I'm using only interact and interact manual. Here I'm applying the decorator, which will allow me to select, which will introduce these boxes for me. For 2 boxes it will allow, because in the function I have passed two columns only. Okay, and I'm selecting only numerical values. Select d types will give me, again this is very important function. Select d types will help me select only the numerical columns. Okay, um, again, just you have to remember, this is still statistics class only. So don't break your head if you don't remember this. We will do a proper data analysis there. I will walk you through on every one of them. For now, select data types, you remember that it is used for numerical types. If I type object here, okay, so it is, see, it is so selecting only the columns that have ABCD, I mean alphabets. Okay, um, for first one. If I run number, then it will select only numerical columns. ID, for example, ID, MS Club, whatever they are, it will select. I think mostly we have numerical values only. No, we have this one also. See, reg1, alpub, nan. So these are all alphabets, right? So That is the difference. For select D types, if you provide object, it will select objective types. Okay. So if you want to do a simple correlation, now what is correlation? Correlation is nothing but correlation is nothing but two different columns. Okay, two different columns will have some sort of common correlation, so some sort of common pattern they exhibit. Okay, so so that um, correlation, right? Correlation means relationship between two different features. Okay, you take any two variables, it will exhibit some sort of relationship between them. Okay, that is called as correlation. Correlation is by definition is nothing but the, if you consider two or more features, what is the relationship between them. Sometimes they will exhibit very strong relationship, and sometimes they will exhibit very weak relationship. Very strong relationship means it will show you a line like this. Okay, so this type of line will exhibit the strong correlation, strong relationship, and weak relationship is, let me draw this. Okay, um, so any arrangement, if you see the arrangement like this in this direction, and if you plot, it could be scattered also, it could be here also. Okay, but essentially it will be in this direction. In this direction, it will start here closer to origin, and it will go here. In this case we call it positive. Okay, so likewise you sorry, likewise you have another type one. Okay, this direction, in this direction if you get, we call it as negative correlation. Okay, negative correlation. So so that is what you see. This is strong correlation, this is positive correlation. This is negative correlation in this direction. Again, positive strong correlation means you all the points are close by arranged. Okay, and weak correlation means they are spread, little bit spread, but nevertheless they show the same line kind of. uh, and if the values are spread, this is important, what we are looking at is extremely important. So this is positive correlation, this is no correlation, and this is negative correlation. If the data points are spread like this, it could be weak or it could be strong, but doesn't matter, it is negative correlation. This is positive correlation, and this is no correlation. Okay, so this will tell us the relationship between any two variables. Okay, so any two independent or dependent variables. So we also call it as Pearson correlation. Okay, and this will help us establish certain relationships, linear relationships. Pearson correlation is for linear relationships, and then there is another one. Okay, like Kendall correlation or other ones for non-linear relationships. So that we will see later on. But for now, here what I am, as a part of descriptive statistics, if you are given a data set, your job is to understand the correlation also. Understand if one feature is impacting the other. Clearly, if you notice, bigger the house, higher will be the sale price. Very simple, right? If your house is big, your sale price will be more. If your first floor area, second floor area will be more, sale price will be more. Likewise, ground living area, if that is also high, then you will get higher price. Again, people will see whether it has full bathroom, three half bathrooms, etc. If the house has a fireplace, so basis on all this factor, your sale price of the house will be high. That you have to understand. So that you can calculate by running this correlation. You can select one column here. Ideally I would select the prediction value, what I want to predict. Basically, in this example, we want to predict sale price, how our sale is going to be, basis on all these various different features that we have collected. So first column I will keep it as sale price, and then I will start calculating the correlation. So MS subclass, whatever that stands for, okay, um, house house price uh, data set description. So if you run this, you have all the description of that data set somewhere here, either on the Kaggle or wherever it is. You can go through what each column stands for. Okay, here it is, information. Okay, ms ms, let me see. Okay, so if you see MS somewhere here, it will be MS sub whatever it is. So you will find that. Okay, or maybe it is not in this particular, because they are using only 31 columns. Maybe in the original data set you will have it. Okay, so there you can check it out. Where was that? Um, there was a particular. Okay, I will find it out where exactly this data is coming from. I think it's coming from UCI repository. UCI repository house price data set. Huh. Okay, this is the data set, but what is the description? Housing price. Okay, they have taken only 6 features. Anyway, I will find it out where these features are coming from. But wherever they are coming from, so you can see the description of each one of these. So your job is to understand how this sale price is being impacted with each and every one of the feature. Okay, so correlation usually you will calculate for any two columns, not necessarily sale price. But first I will do the sale price. To sale price I want to check how it is impacting. So if you notice, this is positive correlation. That what it means is, again interview question, if you plot this correlation, they will ask you to explain what do you understand from this correlation. What it means is 35% of the data that belongs to lot frontage is able to predict sale price. Okay, 35% of the data is generating a pattern to predict the sale price. That's what it means. Likewise, if you check lot area, 26% of the data is generating year build. 50% of the data is able to predict the sale price correctly, year build, using year build. Okay, let's see, using bathrooms, how many bathrooms are there? 56% of the houses have correlation with sale price using bathroom. Okay, likewise, let's check first floor. 60%, see, 60% of the sale price is increasing only because first floor has higher area. That's what it means. Okay, again we can plot this in a, here we are comparing column by column. We will plot and check. Pool area is not impacting your sale price. See, it's 0.09%. That is 0.09. Correlation is 9.2%. Not much impact. Okay, again miscellaneous, there are some other features called miscellaneous features. Those are also not adding any value for the sale price. Okay, this MO sold is also not causing any price. Mainly, how much garage area. See, if your house had a garage, then your sale price would increase. 62% correlation, that is huge. Okay, likewise, fireplaces we saw, garage yield. Okay, how many garages you, how many cars can you park in that garage? 64% impact is there. Okay, so likewise, if you see other um, values, open post, 31%. Okay, there is an impact. This way you have to understand the correlation. And not only with the sale price, you also have to understand the, you also have to understand if there is an impact between this relationship between this sale price. For example, full bath you have, and half bath, half bathroom, bathrooms. So there is a correlation of 13.6% only, which is quite less, I would say. For first floor and second floor, let's see, and then I will explain you what it means. For first floor and second floor, there is very less correlation. Okay, so wherever your correlation is high, you can't use those features. If your correlation between two features is high, then you can't use those features, simply because both the features are predicting the generating the same pattern. Okay, similarity is what it means. Okay, correlation you can if you want to understand correlation, you can substitute it as with similarity for now, for your understanding only. Okay, so here I'm not finding any variables, any columns that have high correlation. If there was high correlation, then we'll have to remove one of those. Again, we have to decide which one to remove basis on certain tests and certain criteria that we will see in data analysis. For now, this is what you do. Okay, correlation. And after doing correlation, you will also have to do the object type. See, for object type also you have to do the correlation. Here it's not working because you can't run the correlation for d types of objects. Actually, this ideally should have been object and object. Okay, never mind, it's not working, don't worry about it. Okay, ignore this part. For object types, I will show you some other way to do it. Okay, again for number, again they have done the for number one. Again they have calculated a scatter plot here. Here they have, here they are calculating the correlation. Here they are doing the scatter plot. I don't know why it's not running, but that's okay. I will plot the scatter plot separately. Okay, uh, don't worry about this. Next, you understood what columns are there. Okay, you can just call the columns and you will get the columns. Okay, all the columns. And sale price is called as target variable or dependent variable. Okay, all these are independent variables. Okay, anything other than the feature that you want to predict are called as independents. These are all independent. This is called as dependent variable. Okay, remember that. Next, you will run a info. By running info, you will immediately get to know what are the missing values out of these 1460. How many values are missing? See, there are only 91. That means there are a huge number of values are missing here. And you will also get to know what is the type of column it is. It has character type. Okay, this is float type, this is int type. So that way you will immediately understand the types of the columns. Okay, um, next, you want to check various features. I mean, again, this we have already done above as well. Here we are checking the describe function only, but for one particular function, but one particular column by column we are applying. So if you type street, it will apply, it will calculate these values for me street. But we have already done this. I mean, no need of doing extra again. You can directly go through here somewhere. For example, this is there, you can just read through. That's why describe is there. This is just another way of doing. Okay, by column, if you want to make use of this, column by column also you can do. Okay, here we are seeing how the values of sale price are spread. You can, what you can do is you can do another thing. Cbon, we have something called hist plot of, you can pass data of sale price. You can understand how your sale price is moving. Okay, so you can see count versus sale price. Okay, so a lot of houses have been sold between 1 lakh and 2 lakh dollars. This is again the prices are in dollars here. So 1 lakh to 2 lakh dollars, a lot of houses are sold. So majority of the data is here only. Very few houses have been sold for 7 lakh, 6 lakh, 5 lakh or 4 lakh dollars. Now my question to you is, what type of distribution is this? Can anybody tell me immediately? Do you remember or not remember? Forgotten already. What type of distribution is this?
Linear.
No. out of the distributions that we learned, chi-square distribution. Okay, so you will see the skewness in the data. Just by looking at it, you should understand. See, it starts from here, goes up until here, then it starts to reduce. Okay, so
Right.
this could be a potential chi-squared distribution. Again, there are very similar distributions. Only after running the test you will understand what exactly is the distribution it is fitting to. But it is definitely not exponential. Definitely not exponential. You can tell from that. It is definitely not Gaussian, because Gaussian will always have this spread of values here in the middle, here, somewhere here, like this. Okay, it is definitely not normal, definitely not exponential. And likewise, what are the other ones? Definitely not f squared, because for f squared again, it will show from here only, it will show the increase and then it will go like this. Okay, increase will be somewhere seen here. It is definitely not f squared also. So this fits the criteria of chi squared. Okay, all right. So we are descriptive statistics means you have to explore what the data is telling you. Here you can see, you immediately by looking at this graph you can make out of two different things. One, the distribution itself. Okay, and the second thing is skewness. Skewness you can calculate immediately. um, okay, for this, skewness means how much it is away. One second. Okay, so if the skewness was 1, it would have been a normal distribution. If the data was here, skewness would be 1. Okay, if the skewness is higher than 1, that means the values are shifted towards left. If the skewness is less than 1, the values are shifted towards right. Okay, that's what it means. Skewness means majority concentration of the values are on the left. So you can immediately make sense of skewness. Okay, and the second thing you can understand is, look at your mean. Where is the concentration of the values? Median is here. Middle values will be somewhere here. Median. And if you immediately calculate the mean of this, notice, no, mean is also somewhere here only. Mean, median, okay, these are here only. And if you calculate median also, middle value, okay, that is also somewhere here only. So median is here, middle value, this bar. Okay, mean is here, this bar, maybe, okay, this bar. And that means if your mean and median are on the left side, what would be potentially your standard deviation? That also you can immediately calculate. That means what you are trying to calculate is how far away on average are the points. uh, okay, let me calculate all of them simultaneously. Okay, so 79,442 on is the value of the sale price on average. Okay, the houses are so basically what it means is, standard deviation means, on an average houses are either underselling or overselling by a value of 79,442. On average they are getting sold at this value, but there is a difference of 79,442. Either increased price, the customers are paying more price, $80,000, or paying $80,000 lesser price than what they are supposed to pay. That is what it means. Is this clear? How far away your mean is, your point is from the mean, is what it is telling. Okay, if you want to go to a market, purchase certain item, okay, you will any person, what will they do is, they'll first ask the price in 4 to 5 stores. Okay, let's just say you want to purchase gold, you won't directly go to the store and purchase the gold. No, you will inquire. Okay, at 4 to 5 shops. And then If you are a statistics person, what you will do is you will immediately calculate the mean, immediately calculate the standard deviation. Then you will say, okay, this store number 1, okay, is telling me so and so price, for example 6200 per gram he's saying, and on an average it is 5800. That means he is charging 400 rupees per gram more for me. I should not purchase there. Second store is offering me 6000, which is again 200 points greater than the standard. 200 points is greater, I mean that is standard deviation is 200 points. That means on an average I will incur a loss of 200 points if I go to store number 2. Store number 3 is offering me at 5700, which means 100 rupees saving I will do per gram, which means there is a, on an average between the four stores there is a standard deviation of 100 for this third particular store, hence I can purchase there, something like that. Okay, this is what it is. Okay, so how far away your points are from the mean is what the standard deviation is telling. Okay, that means the broker must be telling 80,000 points either greater or smaller value from the average to sell those houses. Okay, so that's what it means. Next, mean we already have calculated. You have functions for all of those, you can directly apply. And the disadvantage of applying a mean is highly affectable. I mean it gets affected by outliers. Now what is an outlier? Outlier is a point that shows rare occurrence, or by their rare occurrence they will have huge values. For example, let's just say for let's just say the salaries on an average of students, okay, or the employees is 50,000 on an average, just for the sake of example. But one person has 2 lakh salary. If you try to compute the mean, okay, one person has 54,000, okay, another person has 62,000, and another person has 49,000. And if you calculate the mean of these, okay, this has to be a array, np dot array only, so that you remember you can't apply mean directly. Okay, so on an average, okay, this value is wrong. On an average the salary is 55,000, but if outlier is something that affects the mean. But if somebody comes that he has a salary of 2,50,000, okay, now see what happened. On an average the salary became 1 lakh, although that is very far value, standard deviation is huge, 50,000 points away from the mean. Okay, if you calculate the standard deviation, that's like what is it, like 50,000 points away. So this clearly this one person changed the mean by lot. Okay, this is very important point you have to understand. So mean gets affected by outliers. Okay, so that's why we say mean is not a good measure. Basis on your mean you should not decide what type of values are for skewness, to handling the skewness. So so if there is a skewness like what we saw above here, 1.88 skewness, then we don't choose mean as a good measure, but we rather go for median value as a sale price. Here we are considering median, so that also you can calculate 1,63,000. These are all the steps you have to do in your analysis. Okay, by the way, again the next concept is interquartile range, median and interquartile range. Quartile, what is meant by quartile? Quartile is nothing but so much percentage of values. For example, if I say 25th quartile, okay, taking going back to the example of students scoring the marks, or maybe the employees getting the salaries. Okay, so quartile means if I keep on adding more and more values here, I can say 25% of the 25% of the employees earn so and so number. Okay, for example here in the same house sale example, if you consider um, here they have not calculated 25th percentile. Okay, so here above 25th percentile you have. Okay, what it means is 25% of the houses have, okay, 7,553 square foot of area, total lot area, and 50% of those have 94.9478.5 and 75% have these, and maximum value is this much. Okay, that is what it means. So quartile means, quartile 25th percent quartile means so much percentage of values are lying in that range. So generally Q1 we call it as 25th percentile. Remember, again, this is important. Q1 quartile, okay, is nothing but your 25th percent of the values. Q Q3 quartile, we don't worry much about Q2 quartile. Okay, for in um, this is 75th percentage of the values. Again, Q2 quartile is, although we don't generally use Q2 quartile, but just for the sake of knowing things. Okay, so Q3 quartile means 75th percent values, and Q1 quartile means 25. So if you want to know how many of these houses have, I mean these houses with higher prices have affected the mean. If you want to know how many, I'm repeating very important concept also. If you want to know how many of these higher outliers have affected your mean, then you will calculate quartiles. Q1 quartile you will calculate. We have a standard formula for this. You don't have to worry why this is or how this has come. Just remember it is the way it is. Okay. So we have to calculate interquartile range. Interquartile range is nothing but Q3 minus Q1. Q3 minus Q1. Okay. Now don't say why calculate Q3 minus Q1. You can directly take Q2, no, 50%, because 75 minus 25 is 50%, no. So that way you can take, no, you don't ask such questions. Why? Because very simple, because these are percentage values, these are not direct values. If they were exact values, numerical values, then what you say would have been correct. You could have directly taken the 50 average of whatever the Q2 value was, Q2 quarter value was. But these are percentages, they don't necessarily indicate frequency. Okay, they don't indicate the number of values. Okay, they don't they don't represent exact value, but instead they are percentages. That's why we don't consider Q3 minus Q1 is not equal to Q2 here. Okay, Q3 minus Q1 is called as IQR, interquartile range. You will hear this a lot number of times. Interquartile range. Actually, I'm using this interquartile range to calculate anomalies for one of my use case currently. Okay, so in my current organization, so Q2 interquartile range, and then we have Z scores. Okay, so all these things are used for calculating the anomalies that we will talk about when we do the data analysis for anomaly detection. For now, just understand this is called as interquartile range. And it turns out that if you subtract, by statisticians have proven that a general approach to detect outliers is by doing the IQR calculation, or which is nothing but for lower bound outliers. This is the formula. Upper bound outliers, or that is the higher valued outliers, you have the formula called Q3. I think that is plus. Is that plus? Q3 minus Q1. I think it has to be plus only. Yeah. Q3 plus 1.5 into IQR. Okay. This is very important. You have to remember. Okay. This is called as interquartile range. Okay. Interquartile range is 75th Q3 minus Q1. And if you multiply 1.5 times that IQR and subtract from Q1, then you will get the lower outliers that are less than 3 sigma, 3 standard deviations. Okay, less than 3 STD, standard deviations. Here you will get outliers more than 3 standard deviations. Okay, 3 STD. So that is what you can see in the graph. Actually it's not exactly less than, but anyway, fine, it's fine. So Generally this is what the accepted range is. Okay, so for example, if you take this data, sales data that you have, I will calculate here sales. um, so sale price is this. Okay, you have 1460 values, and if you, for that, if you apply a quantile of 20 26%, sorry, 25%, quantile of 0.25. So this is your q1. q1 equals to this, and q3 is nothing but your 75% of the values. Where are they lying? Okay, you can calculate q3 also. Okay, they have done it already here. Okay, fine. So median is the middlemost value. The way how you calculate IQR is the median is the middlemost value, and Q1 is the quantile of 0.25, upper quartile is 0.75. Then you subtract, you will get IQR. Q3 minus Q1 is IQR. You will get the IQR as 84,025. Now this IQR, okay, so what it means is, so this is a box plot. This is what it looks like if you plot up, if you call box plot using Seaborn for that particular column. This is what it looks like. Now see what this, all these points that are above this value. First let me explain this plot. This lower value is the minimum value. Okay, this is the minimum value. Highest point is the maximum value. Okay, and this box you see, no, it didn't work. Okay, anyway, fine. So this, if I apply to this, no, still the same. Okay, fine. So this box you see, the lower, this first line that you see here, this is called as your q1. Okay, the middlemost value is called as median, and this is called as your q3. So essentially your interquartile range is this box only. The area of this box is interquartile range, and this is your minimum value, this is your max value. So essentially by plotting this box plot, what we can see is, up until this point, we could see that the points were within the IQR range. Okay, or um, normal data points, we call them as normal data points. Anything after this line, after this line, anything that you have is outlier. So clearly by just by using box plot or Violin plot, okay, Violin plot also you have spelling mistake. Okay, Violin or Violin, yeah. So even by using Violin plot, you can see that this is your minimum value. Your IQR starts here, and it ends up until this place. So anything above this line that you see is called as, are all of those are outliers. This is how you can find out the outliers. Basically, IQR is one methodology, or you can put it back to box plot. Okay, either way you can calculate that. And here they have shown the complete value. Outlier lower limit is this, outlier lower limit is high. So any points outside this range are outliers. So basically when you do the data analysis, these are all the steps you have to do. You have to find out which are all the outliers, how they are affecting the mean. Okay, and is there which model, basis on this which model you can choose. I want to stop till here because we have been continuously doing this. Are you, I hope you're following. If not, just let me know, ask, stop and ask me the questions please.